All right, let's take a look. We're going to do another type of grouping, another kind of a factoring, and it's called grouping. That's why I said that. All right, so we're going to, you'll see some problems. Ooh, look at that. It's crazy looking. Let me change this and this first so it writes correctly. Okay, now we're good. We're going to do some more factoring, but we're going to factor by grouping. And I'll show you what that means here. All right, but that's the title of it. And you're even going to see these on the homeworks, and you'll see it like on the test and quiz when you have it on this. I even break it down into sections where it says, okay, factor by using the greatest common factor, factor by grouping, factor by some of the other things that we're going to learn how to do. So that's kind of nice of me, to tell you the truth, because a lot of teachers wouldn't do that. They would just put all these different jumbled problems on there, and you got to look at it and figure out which way you're supposed to factor it. But I help you out a little bit. I'm probably a little too nice on this, but I help you out a little bit, and I organize it. And I'm like, hey, this is this type of factoring. This is this other type of factoring, all right? So it makes it a little bit easier for you. But this is the second type of factoring, and it's by grouping. So let's do an example. That's the best way to teach this. And it's still, factoring by grouping is still using greatest common factor, but using it just a little bit differently. All right. And that's what this will say. It'll say factor by grouping. It's exactly what it says. All right, now let's take a look at it. Let's think back to what we did yesterday and the greatest common factor. Norval, you getting all this? All right. So let's take a look. Is there anything in common with all four of these? Look at it. This has an m and a p squared. Look at this one. This just has an m. It doesn't have a p squared. All right. But this one has a p squared but not an m. And this one doesn't have either one of them, right? So is there anything in common with all four of them? Now there's an m in these two, right? There's a p squared in these two, but there's nothing in common with all four of them. So what we're going to do is this. We're going to group the things together that have some things in common, all right? Let's see. You could probably do this a couple ways. Let me see how they do this. They do it just like this. Now look. Oh, that's 21. I was going to say. This is not going to work out the way I thought it would, with that being a 2. That's a 21. I just misread it. All right, so what we're going to do is this. Look at this. This one has an m and it's got an m, doesn't it? All right. You know what? Did I? Yeah, mp squared, 7m, 3p squared. Yeah, we're cool. So watch what we're going to do. So what's the greatest common factor with just the first two? What is it? An m, right. There's an m in both of these, isn't there? Okay. Look at this. Look at the last two, 3p squared and 21. Is there a greatest common factor with those two? Is there anything that divides evenly into both of those? 3 does, right. 3 does. So what I can do, now, you could have mixed it up a little bit and put the mp squared next to the 3p squared and factor out a p squared. Now, you could have done it that way.
And put the 7m and the 21.
And the 7 and m and the 21 together. You could have done that if you wanted to group those together. But if we just want to keep it in this line the way it is without like moving stuff around, we could just group it like this. Watch how I'm going to group it. I use parentheses to group things together. So I'm going to take these two and I'm going to factor out a greatest common factor just from this parentheses right here. And then I'm going to take this group right here and I'm going to factor out a greatest common factor from this little group. Now, again, you could have done it a little bit differently. You'd still come up with the same answer, but this is kind of a nice way to do it because you don't have to like move things around and put the p squares next to each other and the 7m and the 21 next to each other. Okay, this already has a greatest common factor. This already has a greatest common factor. Does it make any sense? All right, so that's all we're doing. We didn't really change anything at all, did we? We just put parentheses around it. That didn't change it at all. But now what we can do is we can do greatest common factor just with these two right here. Hello. Oh, I'm updated. Thank you. I was like, wow. I thought there was angels coming down from heaven. Sounded nice and pretty, didn't it? All right. So what we're going to do is take this little parentheses and factor out the greatest common factor. So what is it? What's in common with both of these terms? M. Yeah, it's easy to see. And what are we going to do? We're going to put a parentheses just like we did yesterday. And if we factor out an m from these, what do we get? We get p squared plus what? 7. Good. All right, we're just going to leave that there for a second. Then we're going to do a plus. It's kind of like 2 factorings in one. And actually, in the next step, you're going to see it's actually kind of like 3 factorings in one problem. All right, but I don't want to get ahead of ourselves. Look at this. 3p squared, 21. What's in common with both of these? You said it earlier. It's a 3. So we factor out a 3, and let's find out what's left over after we factor out or divide out a 3. So what are we left with here? P squared plus what? 7, right, because we got to divide everything by 3. 21 divided by 3 is 7. All right, we good so far? It might look like you're done, but we're really not. Remember that last example we did yesterday, right when we were walking out the door, and we had parentheses there? Look at this. This is one term, isn't it? And this is another term right here. Do you have anything in common with these two terms?
Plus 7 and p squared.
The p squared plus 7, that's right. So we have a p squared plus 7 in common with this, and we have a p squared plus 7 in common with this. And it's being multiplied by both of them, isn't it? So we can actually factor out the greatest common factor again. That's our third factoring for this problem, isn't it? We factored once here, and then we're going to factor one more time, and we're going to factor out a p squared plus 7. So let's do that. So if I factor out a p squared plus 7, what are we left with if I divide this by p squared plus 7? An m. Plus, right, factor out a p squared plus 7 from this, we're left with a 3, and there it is. Now it's factored. Remember what factors are. Factors are things that are being multiplied together, right, to get that product, to get that answer. So it's not completely factored right here. It's not completely factored. Now we did factor a couple things, but you still got the plus sign right there. It's not like you have just one thing times another thing, do you? But here you do. You've got one thing, p squared plus 7, times p plus or m plus 3. That is now completely factored. Now, you probably don't want to do this on a quiz or test or anything, but you could check to see if you got this right. Okay, what would be a way to check to see if this is actually your right answer? Yeah, FOIL it. Multiply it together. Do distributive property, right? If you wanted to, you could, right? First, outside, inside, last, and you would come up with exactly this. All right? And if you didn't, you did something wrong. Either you checked it wrong or you did the problem wrong. That's what always confused me when I was a kid, and the math teachers always say, okay, check your work, and you got to do this and this. I'm like, well, yeah, but what if you make a mistake checking your work, right? So, I mean, if you make a mistake getting your answer in the first place, your answer's not going to check. But if you get the answer right and then you check it incorrectly, you're still not sure if you got it right or not. So at some point, you got to get some stuff right, either the checking right or the original problem right. Would you agree? All right, so, but anyway, yeah, I think it is, sometimes it's important to check. You could do it real quick, couldn't you? First, outside, inside, last. Let's do it real quick. First, p squared times m, or mp squared. That's it. Last, or outside, sorry, p squared times 3, or 3p squared. That's right there. Inside, 7m. That's right there. And then the last, 21, right there. It didn't take long to check, did it? All right? Didn't have to write it down. Just kind of do it in your head real quick. Yep, I got it right. It's in a different order, but that's fine. It doesn't have to be exactly in a certain order. It's good to go. Make sense? It's not too bad, is it? That's factor by grouping. Let's try another one. That was pretty easy because everything's plus in there. What if they throw some minuses in there? Well, I'm glad you asked for that because that's what we're going to do. Did you ask for that? I thought I heard you, Morgan, asking for put some minuses in there. You didn't say that? Well, can't promise you. On this one, there's not. But by the way, while I'm thinking about it, do you have my zoom lens I let you use? Okay. Okay, good. Thank you. Because I'm going to get Nick to practice with that lens. All right, here we go. Do you do anything in the fall? Like any sports or anything? Are you going to do cross country? Okay. Because I need a photographer that will shoot sports in the fall for me.
She can handle cross country when she's not.
Can you run with the camera and then take pictures as you're running? All right, let's do this. Here we go. We got to group this thing together. Let's see. Is there anything in common? All right, Tiff. Are we going to? Tiff, we're ready to go. Are we going to factor something? Is there something in common with all four of these? No, because there's a 2. There's not a 2 in everything. There's a y squared. There's not a y squared in everything. So right there's nothing that goes into all four of them. But we could group them together. What about the first 2? Could we group the first 2 together? Is there anything in common with the first 2? No, there's not. But what about the first one and the third one? Yeah, there is. There's a 2 in common, right? So we can group those together. In the next step, I'm going to actually write them right next to each other. Okay, what about the other 2? Is there something in common with those 2? Yes, there is. So let's rewrite it so our groupings are together, all right? So let's take that 2y squared. Remember I said you could have done this with that other problem, but it was easier on that other problem. So we're going to put this next to this. Remember, there's a minus here, so it's a minus 2. That minus, or that negative, goes with that 2, so it's got to come around here too, all right? So there's 2y squared minus 2z. Let's do the other one. This is a positive az, so plus az, and then minus ay squared. All right, so sometimes you got to rearrange things a little bit, and that's what we did. Make sense? So now we're going to group these together, and then we're going to group these together. So let's do it a little faster than what we did earlier. There's a 2 in common with both of these, so we factor out a 2, and we get y squared minus z. What's in common with these two? An a, right? And what do we get here? We get a z, what? Minus y squared. Let me see something what they, I just want to see what they, I know what I'm going to do. I just want to see how they say it. Alright, I think I figured it out. Watch this. What's negative 1 times negative 1? It's positive 1, okay? So if I took something, if I took like a times b, right? And if I multiplied that by a negative 1, but I also multiplied that by a negative 1, isn't that the same thing that I started with? Everybody see that? Okay. Do you see the problem here? These are not really the same, are they? Y squared minus z is not the same as z minus y squared, because this is a positive y squared, this is a negative z. Look at this. This is a negative y squared, and this is a positive z. It's not the same thing. They're opposites to each other, aren't they? But think of it like this. What if I took this a and I multiplied that by a negative 1? That would be a negative a, wouldn't it? Okay. But then what would I have to do, though? See, I made this negative, but I also have to make the other factor negative as well, don't I? In order to not change it. I can't just make this negative. So what am I going to have to do to this? I'm going to have to make this negative as well. So watch what I'm going to do. Now I've got to change everything in the parentheses, right? So that would make it what? Negative z and positive y squared. Do you see why I can do that? Because all I did, I multiplied this by a negative 1, and I multiplied this parentheses by a negative 1. So really, I just went negative 1 times negative 1, which is what? Positive 1. Did I really change the value of it at all? I changed the look of it, I changed the signs, okay, but I didn't change the value of it because I multiplied both of these things by a negative 1. I hope that makes sense. Go back and listen to it on the YouTube if it didn't make so much sense. So let's rewrite this a little bit. Okay, now instead of plus a negative, you know how to write that. You can just put minus, couldn't you? But what's this going to be? Now it's a negative z, so is this. Now it's a positive y squared, so is this. So if I wanted to write it, I could write it just like that. See what I did? I basically just took this, multiplied it by a negative, took this parentheses, multiplied that by a negative. I'm allowed to do that. Why am I allowed to do that? Because negative times a negative is a positive. So really, in effect, I really did not change the value of it at all. I just kind of did a little finagling. You ever hear that word? Just messing around a little bit with it, okay, and playing around with it, and but I did it legitimately, okay. I did it so that the rules work, okay. I didn't just say, you know, it'd be really nice if that was the opposite sign and just make it the opposite sign. Well, you can't just do that. You got to follow the rules, and I did follow the rules. I made this negative 1 times this negative 1. Really, that's the exact same thing as what we have right here, okay. So now we have a greatest common factor, don't we? So let's do that. Let's factor out what? A y squared minus z. That's in common with both of these things. All right, we saw that earlier. Hopefully you see it again. Now, if we factor this out, or we divide this by a y squared minus z, we get a 2. Put my sign down, negative. What if I factor out a y squared minus z from this? What am I left with? An a. And there's my factor. Now it's completely factored. This right there is exactly the same as what we started with. Go ahead and FOIL it and see if it really is. Here's what I'll give you. I'll give you this worksheet. We're not completely finished everything for the worksheet, but you should be able to do up to number 6. All right. So then tomorrow when we finish, you won't have to do all of them. Okay. So I'm going to give you, and all you got to do is up to number 6.